Hello everyone, welcome back to my channel. This is Karama. So in today's video, we are diving into three important questions about salary trends using data visualization in R. So we will explore how experience, gender, and age influences salaries and uncover some fascinating insights from the data. So first of all, we're going to answer three important questions today. And the first one is, what is the relationship between years of experience and salary, grouped by gender? So we will see how salaries evolve with experience and identify any differences between men and women. Second, we will also go further to discuss about how those gender influence salary distributions. So is there any noticeable salary gaps between genders? We will visualize and discuss what the trends or the data reveals. And finally, we will look at how those age correlate with salary and what trends can be observed. We will also explore how salaries change as people grow older and highlight any interesting patterns. So if you are into our data programming or you're just curious about salary insights, so stick around. By the end of this video, you will have a clear understanding of these trends and how to visualize them effectively. So let's jump into the code and see what the data tells us. All right, let's load our data first. Sorry, not now. All right, so our data set is loaded with 375 rows and we have 6 variables. So that's we have age, gender, education, job title, experience, and salary, having 6 variables in our data. So we're gonna use those 3 questions to answer them using this data set. Now let's examine if we have any missing values in this data. Call some. We have age have 2 missing values, experience have 2, and salary have 2. So because this missing values is not many in our data, so we will instead remove these missing values in our data set. So let's add another line of code here called na.omit. Alright, so let's run this code again and examine the missing values. So the missing values have been omitted, been deleted using this line of code. Alright, so now we will go ahead to answer our first question, that is about what is the relationship between years of experience and salary, grouped by gender. Now first we have our ggplot and we have our data. Now aesthetics here is, when I finish typing the code, I'm going to explain to you what each of these line of code is trying to tell us. So the color is gender, and we have geom point, and we specify our labs. So the title we want to give to our graph is experience versus salary by gender. And our x-axis we want to have years of experience, and our y-axis we will have salary. Alright, so that's all we have to do. So we have our plot, but let me explain to you about what is happening in this line of code. So this line of code, ggplot data, aesthetics, experience, salary, color is gender, is trying to set up a scatter plot using the data frame that we have here, data that we just loaded. Now the experience is plotted on the x-axis and y-axis is salary. Now the color here is that gender would differentiate points by gender, that is males and also females, which is called by from the geom point. And we also have a scatter plot because we have a point here. So the point here is going to be a scatter plot, which is going to plot a point to visualize the individual salary data points. So the labs we have here at the end part here is the labels our plot for us, our title, our y-axis, also our x-axis. Now, if you look at the key observation we have in this graph here, generally we have a positive trend. That means the salary increases with years of experience for both males and females, which shows a positive correlation. Now, at the gender differences, when you look at the lower experience level from 0 to 10, the salaries for males and females appear similar with some overlaps. But looking at the higher salary experience levels from 15 years to 25 years or 15 years or more, males tend to have a higher salary range compared to that of females, with a fewer male outliers, which earning potential goes significantly more, up to like 250,000 at this point here. Now, looking at the distribution part, we have the males, which is the sort of blue or green stuff, and we also have the female, which is red color. So the male shows a broader salary spread, particularly at the highest experience levels, and females are relatively clustered with fewer high salary outliers compared to that of males. So the overall explanation I will give to this plot is that the plot highlights how experience influences salary across genders, with potential disparities emerging as experience increases, warranting further exploration into factors contributing to these differences. Now, in our second part, what we're going to look into is how does the average salary differs between genders? So how does gender influence salary distribution? Now, what we're going to do is we also bring in our ggplot, and we have our data, and X is gender, and we have a Y salary, and we fill with gender, and we have start summary, and in that we have the function, we use the mean, and we use the bar, and position we use the dodge, and plus we want to add labs. X is gender and Y is salary. Alright, let's see what happens here. So it's ggplot data, we have our aesthetics, X is gender and Y is salary, field is equals to gender, that's correct. Plus our start summary, the font is mean, that's correct. And our geom is equals to bar, that's also correct. Position is equals to dodge, that's also correct, plus labs. Title is average salary by gender, and X is, we have an, okay, here should be equals to. Alright, so this is plot already. But before we go into the plot, let's first explain the code. Now, if you look at the code, we have the ggplot, this first line of code here. So this calculates the mean salary for each gender. Let's start from the first part here. So this first line of code here set up a bar plot, and the gender is placed on the x-axis and salary is on the y-axis. So the field here is, we use gender to fill colors of the bars of for each gender. Alright, and coming to the second part of the code, which calculates the mean salary for this part. This calculates the mean salary for each gender and creates a bar for the average. So the position dash here, it ensures that the bars remain side by side if there are multiple groups. And then the labs here is to add a title on our title of our plot, and also title of our x-axis, and what is our y-axis. These are x-axis, and what is our y-axis telling us. So the key observation we derive from this plot is that this bar chart compares the average salary by gender and it shows that the males on average earn a slightly higher salary compared to that of females. So the average salary for males is slightly above 100,000, and that of female is close to around 95,000. And the visualization highlights a gender salary gap where males appear to have a higher salary, higher average salary because we're using the mean. And while the difference is not that large, it is also notable and may warrant further investigation to look into factors that is causing or influencing these disparities. And this could be job roles or job titles or industries, or probably even experience levels can also lead to these disparities. But as I said, it could warrant further investigation to see what is actually responsible for this difference. Now, the final question is, we will now look into how those eight correlate with salary. Now, in this, we have our ggplot. And after our ggplot, we have our data, our aesthetics, we have our x-axis, age, and our y-axis, we have salary. And after that, we have jump point. And jump point, we now bring our smooth jump line. Jump smooth. Sorry, yes. What is happening to my hand? All right, jump smooth. And in jump smooth, we specify the method we want to use, which is a linear model. The method we want to use is the LM, which is the linear models. So the standard error, the SE, we will set it as false. And then the color we want to use for our line is, let's use blue. Blue looks good. All right, so let's identify, let's set our labs. Plus, what is the plus? Labs is going to be the title, let's say relationship between age and salary, and our X is going to be age, and our Y is going to be salary. All right, good. So let's first explain about our line of code here, and then we will go further to give our key observations from this plot. Now, this line of code, we have the ggplot. This part set up a scatter plot. Now, age is plotted on the x-axis and y is on the y-axis. And in the jump point, here we have jump point. This jump point adds a scatter plot point to show individual salary values by age. And now we have the jump smooth. The jump smooth here sets method, which is the linear model, and SE false and color is equal to blue. So this line of code adds a linear regression line, which is the method LM, linear model, to visualize the overall trend. So the SE is set to false, which removes the shaded confidence interval that we're looking at, that we're not much interested in. And the color is blue, which sets the regression line color. That's this blue line we have here. And the labs here, we have, it adds a title and X labels for clarity of our plot. We have our title and we have our y-axis and our x-axis. Okay, so now if you look into this plot here, what is the key observations that we have here is that this scatter plot illustrates the relationship between age and salary with fitted trend line, which is this line. And the key observation here is that the positive correlations that we can see, because this line here shows that salary and age are positively correlated. Now, there is a clear positive correlation between age and salary. That means as age increases, the salary also tends to rise. And the trend line, which is the blue regression line, highlights the overall upward trend. This indicates that the older individuals generally have higher earning potentials or higher earning salaries. Now, if you're looking at the data spread, because we have three things, the key observations, we have the trend line, and also the spread of our data. Now, in the data spread, the salaries vary significantly for individuals within the same age group. If you look at the plot carefully, you can actually visualize that, particularly in the age from 30 to 50 age range, where some earned much more higher salary than others. And salaries also become more dispersed as age increases, with few individuals having exceptionally higher salaries up to like 250,000. So this is all about the video. Now, in conclusion, what we're going to say is that our data visualization reveals some key insights about salary trends based on experience, gender, and also age. So the relationship between years of experience and salary, when we group by age, we observe that, that's the first one, that we observe that salaries generally increases with years of experience for both genders. However, males tend to have slightly higher salaries, especially at higher experience levels, which indicate a possible gender gap as the career progresses. But this might not be realistically the same as the current 21st century, as things change very quickly. And also how gender influence salary, that's this one. So we have a bar chart that shows an average earning, that's the bar chart shows that males have higher earning salaries compared to that of women. So while these differences may not seem large, after looking at this at first glance, it highlights a persistent gender disparity that absorbs attention. And finally, how those age correlates with salary. That's this part here. Now, salaries increases with age, which shows a positive correlation from this trend line here. So this trend likely reflects a career progressions, increased experience, and also seniority. However, the spread in salaries widens with age, suggesting that other factors like job role or industry also plays a significant role. So overall, the data insights, our data shows the highlights. Our data highlights clear trends, which shows that experience and age positively influence salary, but gender disparities persist. And these findings remind us the importance of data-driven insights to uncover and address inequalities in the workforce. So that's all I have for you again. If you find this video insightful and useful, don't forget to share, like, and subscribe for more data analysis content, and let me know in comments what trends surprises you most. Thank you very much for watching.